Well, good morning, everyone. Hope everybody had a wonderful weekend, and see that everybody is here safe today. That's good. So today we're going to talk about checking refrigerator boards using a wiring diagram, wiring schematic, whatever you want to call it, or using the function on the board. Almost every board has a function where you get your error codes, and you can go through and check all of check everything to make sure that everything's working properly. Um, so let's get right into it. All right. So let's talk about this is a manual circuit board for a refrigerator. You will not find very many of these. Um, there are none that are brand new that are this simple. Um, this is basically whenever I first started out, this was an over under refrigerator, a top mount, however you want to call it. This was the simple wiring diagram that you have, and it was so simple, and it was so easy for you to go in and check what you needed. The only difference is, and I couldn't find one that was this old that still had all the information in. Let's take the defrost timer on there. It only had two pins that were actually active, but you could go in and it told you which pins were active, and when they would be. Just like this is, if you look at it, there's a switch in there. So the defrost timer has a switch. One this unit right here, if you don't know, this unit is in a defrost at this point. Okay. The problem is the defrost thermostat's open also. So I have a bad defrost thermostat. If this is cold, the defrost thermostat is open, so it will never actually go into a defrost. This is one of the things as a technician that you have got to know. Okay, whenever you see this should tell you, number one, that if the defrost timer is in defrost, okay, it goes up to the defrost thermostat. If the defrost thermostat is open, I am going to have to go and get my meter, and I'm going to have to check the defrost thermostat and figure out why the defrost thermostat is open. Okay. That could be as simple as something as simple as it's not getting the defrost thermostat is bad. It's not closing like it's supposed to. Could be that it's not cold enough for the defrost thermostat to set. Once this thermostat reaches 38 degrees, this thermostat opens. Okay, it keeps from somebody melting anything with the defrost heater in the freezer section of the unit. Okay, make sure that you know what you're doing. I had Reggie call me yesterday and asked me to go online and try to help a technician out. I have since I did that, and asked him a couple of questions. So one of the things was, is there anything open in your circuit? What kind of voltage are you getting from the defrost timer to the circuit? Okay. Um, so if the defrost thermostat has its 120 volts, okay, it should be closed unless there's a problem. So in this one, it should be closed. It would run through the defrost heater. Okay, the defrost heater would come on. It would go through its 22 minutes usually. It would defrost everything. Then it would go back into a freeze mode. At that time, the defrost timer would swap down. It would now run through the cold control. Once the cold control is closed, Okay, it would excuse me. It once the frost control, the cold control is closed, it would start the fan motor and it would start the compressor. It takes power off of the defrost heater, that defrost circuit, and puts it back onto the circuit that has the compressor and the fan motor in it. Okay, it's very simple. This is the simplest wiring schematic that they have that is out there. Okay, here's a little bit better. Here's a Whirlpool side by side. Once again, this is not that difficult to go through. All you have to do is go through and so if you look at it, the damper assembly in this model right here is controlled by J1-5. Okay, that's part of the damper assembly. The J6-1 and the J6-2, that is a switch that has to open and close, and that's what opens and closes the damper assembly. So I've got to make sure that I've got all of this done. The evaporator fan motor is running off of the pin J1-4. Okay, so if I need to know if the evaporator fan motor, why it's not running, I can go from J1-4 and over to the neutral, and that will give me a reading that tells me, hey, in today's world, this would be a DC voltage instead of an AC voltage, like it was on the other one. The other diagram was totally AC. There was no DC voltage. Okay, so if I go between those two pins, I should read however many volts it says that I have. The thing that's missing off of this, if you notice, this is cut. This version is cut off. Down below, it would tell me how many volts. Usually it's somewhere around 5 DC volts for an evaporator fan motor. Okay. Once again, that's on J1-4 to the neutral side. Do not go from J1-4 to the ground. Okay, that if you're dropping a neutral, your fan motor may be slowed down and it's not working properly. It could be anything from dropping a neutral and you'll never get the fan motor to come on. So you have to go through your wiring schematics and make sure that you're going through the wire and make sure that you're getting the proper voltage using the chart that you're supposed to be getting. Okay, here's an even more advanced one. Okay, this is a Samsung RF18. If you look down here, there are two different boards in this. Okay, now Samsung, there's about between Samsung, LG, and several of the other OEMs, they've got 4 and 5 boards. Okay, they have boards that are controlling the compressor. We got boards that are all running off this main board. So you may have to go out and you may have to actually go from one pin to another pin on the main board, drive it down and find out where it goes, go to the other board, check power in, see if I have the right power out of the board, and then I can go to the component. One of the things that I learned very young on diagnosing using a meter. Okay, I try to divide the circuit somewhere in half. If I get to the board, usually they're on the back, so I'm going to have to pull that unit out. So the one thing I don't want to do to risk damage is to pull anything that I don't have to pull out. Every time I pull the unit out, I run risk of water damage if there's an ice maker that's hooked up to it. run the risk of floor damage because I have damaged the floor whenever I'm pulling it out. Something was hanging below. Could be something as simple as wall damage, pulling it out. You just never know. So I do anything that I can do from the front of the unit to begin with. So let's say that my evaporator fan motor is running slow. Okay, so the first thing I have to do is go to my fan motor, check my fan motor, and then I'm talking about my evaporator fan motor. Okay, I go to my evaporator fan motor and I check the evaporator fan motor out. Okay, that evaporator fan motor, what else runs that evaporator fan motor? Okay, one of the things that runs that is the light switch. Okay, the light switch is on and off, and if I've got my voltage coming from my light switch to my fan motor, and I'm checking my fan motor and I have the right voltage coming to the fan motor, I've got a problem with my fan motor. If I don't have the proper voltage coming to my fan motor, I have to backtrack. Once again, I can backtrack. Okay, I backtrack by what's next in the circuit. Okay, so what's next in the circuit? If I have power, if I have power to one leg of the motor, and I don't have power to the other leg, I've got to go to the light switch. Okay, they break the common. So I go and I check my light switch. I make sure that my light switch, I have the right voltage coming to my light switch and the right voltage coming out of my light switch. If I don't have the proper voltage, I know that I've got a bad light switch. Okay. And just because you replace a part, that doesn't mean that that part is good. That's the first thing you've got to learn as a technician. Don't necessarily trust that this part is 100% right. Even the manufacturers make mistakes, and 9 times out of 10, they don't produce their own parts. It's produced somewhere else. Okay. So always check and make sure that I have the right voltages like it's supposed to. I have to consult my wiring schematic that it tells me how much voltage I have. Okay. And like I said, this one here is also cut. If you can tell, I've cut out sections that I could get to. So it's usually on the wiring schematic itself to tell you where the voltage is. If it's not on the wiring schematic, you have to go to your manual. Okay, so it's on there somewhere, and it will tell you how many volts you're supposed to get. Okay, so like if you look down on the bottom left-hand corner, looks like line 1, C101 has 5 volts on it. Okay, so that tells me that I should have 5 volts right there. If that's open, then I know that if I don't have it from one side to the other side, I know that I've got a problem, and I'm going to have to check that part itself and get them taken care of, so that I can. And you may have 2 different parts that are bad. One thing that we have that a lot of times I used to have problems with the refrigerator was whenever there was a lightning strike. You 9 times out of 10 you'll spend half a day trying to figure out what in the world all the parts were that the lightning zapped. So that's up between you and the customer. Sometimes you just have to throw up your hands and say, I've done everything I can. But make sure that you've done your due diligence, because they may call somebody else. And if they call somebody else, you have to be ready. Okay. So here's one of the things that you're going to have to know whenever you're whenever you're trying to calculate, okay, what the right voltage is, what the resistance should be, the what the amps are. This calculation right here is called Ohm's law. Okay, Ohm's law is important and functional rule to remember when working on resistors and electronics. It defines the relationship between the component's current, which is in amps, voltage, okay, and resistance. Okay, A stands for amps, D stands for voltage, and R stands for resistance. Okay, there are all the stuff right there. Okay, so Ohm's law consists of three mathematical equations that explain the relationship between currents, voltage, and resistance. If you know two of these values, you can calculate the third using Ohm's law. Okay, the three equations are, and there are two sets of equations here. Okay, one is let's just start at the top. Both of them are one of them has the triangle. It's the same thing. You know, the V is volts, I is current, which is in amps, and R is the resistance. That's the triangle. I prefer the method to the right. Okay, it tells me volts equals current times resistance. Okay, and then if I want to find the amps, okay, amps equals volts divided by ohms. Okay, if I'm going to try to find the resistance, okay, I go from volts divided by amps. That gives me the resistance that I should be in any circuit. So if something happens and it's missing something, if you know two of those values, you can figure out yourself what it should be. Okay? This is one of the most important things as a technician that I need to keep in my mind. The other important thing that is not on here that I have put down is there is a little saying that goes to let you know on a resistor what the color bands are. Okay, we're not going to go into that today. If you want to do that, you can revert back to one of the other trainings that we had, which was your basic reading a wiring schematic. I covered that in reading a wiring schematic. Okay, I'm gonna stop right there for just a minute. Okay. Does anybody have any questions so far? Okay, I'm going to give you about a minute to go through and look at them. So let me know if you have any questions so far. As always, these are recorded. Once we finish today, it will be. I will upload it, and you can see it tomorrow. See it as soon as probably tonight. And you can review this if you need to review it. Okay, last chance. All right, we're going to move forward. Okay, so let's talk about how do I check the inverter board on a Samsung refrigerator. Okay, so the first thing that I'm going to do is I'm going to take and put that board into the FF mode. Okay, so that way the compressor is always running. Okay, I'm going to show you below how to put that into that FF mode. Okay, so the first thing I'm going to have to do is I'm going to have to put flooring protection down on the floor before I pull the refrigerator, because the next thing it says is to pull the refrigerator out and remove the 4 screws on the board. Once again, if I say this one time, I've said it a million times, always protect the customer's property. If you don't, you will end up paying for a floor, a wall, a board. I promise you, sooner or later, you're gonna have a problem, and you're gonna have to deal with a customer this irate. May not be you, may be your boss, but if you're your own boss, you got to protect the customer's information. The first thing that I always had my technicians do is I advanced on through the ranks. I became an owner of one of the managers of one of the repair facilities that I worked at. I started out, and then I had my own. Later on, I had my own. I was a man. It was a one man show, one man band, as I used to say. Okay. But I always had to deal with the customer. The first thing that I would do is I would make sure that the customer was in the room. Whenever I walked in, I would make sure that I checked all around whatever appliance I was working on. I would make sure that there were no scratches, no dents, no dings on the unit, on the wall, on the floor, on the stuff on the side, and I'm going to make note of that, and I'm going to put that on my ticket. Okay. Whenever even if I'm not don't have a manual ticket and I have an electronic ticket, I always make sure that I put all of that stuff on. Okay. Make the customer sign it. Have them initial it before you do any work to the unit. If the customer refuses to initial it, I walk away. Can't afford it because I know that something's hinky, and I'm not gonna put myself in that situation. Okay. I have actually walked out of it whenever I used to work for Circuit City. I walked out of a customer's house and called my boss and said, I'm not doing this. She refuses to sign. There's damage all the way around. We're going to end up paying for this. So it ended up that he called the customer. The customer, had all these bad things to say about me. And he said, well, we've got to go out there. And I said, well, then you're going to come with me. I'm not going to have this on my record that this customer wouldn't sign for this. And then lo and behold, all of a sudden there's all kind of damage and it was already there. So he actually went out there with me. I did what I needed to do. He made note of all of the stuff on the ticket that I had already made note of. And Circuit City was covered. The customer called back and talked to someone higher up, one of the regional managers. We had all the documentation, so we were safe. Okay. Always make sure that you protect yourself. I'm going to get down off of that soapbox. Okay. Okay. So I'm going to pull the refrigerator out using flooring protector. I'm going to pull it out. Okay. I'm going to remove the 4 screws that are around the outside of the board. There's only 4 screws. You can find it. Okay. With the 4 screws removed, tilt the panel back and remove it. Okay. I'm going to make sure that the inverter board LED is lit and not blinking. If it's not lit, you need to test the signal from the main control board. If you don't test this and it's not lit, you got nothing. So here's how to get this into the FF mode. Okay. The first thing I'm going to do is I'm going to press the freezer. The other thing is I'm going to press the lighting button simultaneously. I'm going to hold that for about 8 seconds. When you do, you're going to get a beep. Okay. Don't always think that you're going to get a beep. Okay. Most of the time you get a beep. Sometimes you don't. Okay. But what will happen is it will now revert and put FF in that display just above where it says cubed. It will say FF. Okay. So that's how you make sure that this unit is always has the compressor running. Okay. Here's a little thing. I'm going to remove there's the 4 screws that you're going to remove. Disengage the housing connector and the inverter board PCB, the main PCB and the fuse box. Remove the inverter PCB and the main PCB by pulling the hook out. If you're going to replace it, this is how you replace the board. Okay. We don't have to replace it. I just wanted to make sure that you had pictures of what I was talking about. So you can see the 4 screws. You can see what it's going to leave you whenever you remove those 4 screws and what you're looking for. Okay. Okay. So checking the inverter board. If the inverter board fails, it can cause the compressor not to run. Okay. So that's the first thing you're going to make sure is that the inverter board is good. Okay. Look for the connector labeled VIT comp signal. Place the lead on the ground pin and the other on the compressor pin. Make sure the correct pin by consulting the wiring diagram. As the models change, so does the pin connection. Okay. Never take it that is written in stone. Always go to the wiring diagram to make sure that you know which pins go where. Okay. The one thing is these are fairly large. These pins are not really small. You may need at one time. You may need to get an extension so that I can get my pins taken care of, and I can read the proper voltage. Okay, so I'm going to go between pin number 2 and pin number 4. Okay. So what does my meter tell me? This meter tells me that I'm running 1.858 volts DC. Okay. Make sure that it is set to the right voltage. Okay. If you're trying to get DC voltage, make sure it's set to DC. Okay. The other thing is you don't need 450 volts DC. All you need is if it's supposed to be running at 5 volts, I can select my 5 on my meter. Okay. Make sure that you've got the right one. Okay. On the control board, if something happens, this is kind of the cart before the horse here deal. Okay. If the control board is blinking, like it's not blinking, you've got a normal function. If it is blinking, okay, if I have one blink, it's telling me I have a starting failure. Okay. If I have 2 blinks, okay, it's telling me that I have an SPM fault. If I have 3 blinks, okay, it's telling me an abnormal current detection. Okay. So I am going to make sure that I have all of these, that I'm checking these. If it's not on, I need to know why or if it's blinking, why it's blinking. If it's not on at all and it's dead, that tells me I got to go all the way back to the board and find out why it's not blinking on the board. I have to check my power in, power out. Okay. So here's kind of the old versus the new. This is the original one that we saw on the other slides that were beforehand. So this right here is the old versus the new. This is a Frigidaire that's on the left side and a Frigidaire that's on the right side. Okay, it's just a comparison of old versus new. Okay, the one thing, if you notice, the one thing on this other one is that the light switch is not on this. Oh, it's only the control. Okay, so let's take a look at this wiring schematic as we've gone through several of these. Okay, on this, what wire is line voltage? Okay, I'm gonna go back from full screen. I'm going to go back and somebody tell me on that wire schematic which wire is line voltage. Come on, guys, give me a hand. Somebody tell me what is line voltage? How do I find out which one is line voltage? I can go from the plug. Line voltage would be which one? It's either going to be brown or it's going to be, I think it's orange. I'm sorry, I've got it so small that I can't see it because I'm looking at everybody else. Brown or orange. Okay. Okay. Mike, that is not correct. It's brown. Okay. What color is neutral? That would be your orange. Okay. The blank control, the evaporator and condenser fan motor on the what controls the evaporator and condenser fans? Okay. Who knows? Who knows what that is? Okay. Thanks for piping in there, Mike. I appreciate it. Okay. The blank controls the evaporator and the condenser fans. Okay. What controls the evaporator and the condenser fans? Okay. Look at the wire schematic. What wire? And then tell me what controls it. Trace it back down. Okay. The electronic control controls the evaporator and the condenser fan. Okay. The defrost heater is on. When the defrost heater is on, what is closed? So on the circuit, look at the circuit itself. When the defrost heater is turned on, what is closed? Okay. It would be the blue wire that is controlled from the temperature from the defrost controller. That's what controls the defrost heater. Okay, that defrost heater also is controlled by now it's a resistor. Okay, so the defrost thermistor is closed. Okay, if the defrost thermistor is closed, okay, the electronic controller is closed. Which of these is done? The defrost thermistor is closed. I have both A and C. None of the above. Okay. If it'll be Okay. If the defrost heater is on, what is closed? The electronic controller is closed. The defrost thermistor is closed. Both A and C, none of the above. Somebody give me an answer. The answer is both A and C. Oop. Well, okay. The overload, okay, is placed on what terminal on the compressor? Okay. Which of the terminals does the overload go on? So if I'm plugging the overload in, which terminal does it plug into? Okay. Is it the C terminal that's on the compressor? Okay. Is it the S terminal that's on the compressor? Is it the R terminal that's on the compressor? Is it maybe both R and C that are on? Tell me which terminals this covers. Okay. Okay. Somebody pipe in. Mike did a good job last time. Somebody else pipe in, please. I want this to be as interactive as we can get it. I mean, it's not the greatest thing in the world, being that you're at your own facility or you're under a refrigerator somewhere. But I need you to help me help you. Okay. So where is the overload placed? Okay. Is it the C terminal, the S terminal, the R terminal, both the R and the C terminals? Where does that, if I'm looking at the compressor itself, so you have to go and find the compressor in the wiring schematic. Okay. And I go and I look at it, where, if I'm looking at the wiring schematic, I can tell you where it goes just by looking at the wiring schematic on the overload. I follow it from one to the other. Yes, you're correct, Mike. It is the C terminal. Thank you very much. I appreciate it, you Mike. Okay, so what triggers the compressor to come on according to the diagram on the right side of the page? Okay, it's the answer. The three answers are either A, nothing, it's independent, the temperature control, B is the temperature control, or C is the defrost controller. So this one is a little more in depth. Let's put it that way. So which one controls the compressor? Okay. What tells the compressor to come on? After I have gone through a defrost cycle, what turns the compressor on? Okay. Is it nothing, that it's independent? Is it the temperature control, or is it the defrost controller? A, B, or C? Okay, so the defrost controller is what actually has the unit come back on. Okay, I realize that today's uh, class was a little short. Does anybody have any questions? Okay.